Good morning, everyone, and welcome to day two of AI for All. And we'd like to welcome all of our participants who are just streaming in. So this is going to be another exciting day. So we'd like to thank everyone for joining us today, and as well as those who were with us yesterday. And well, for those who are still joining us today, AI for All is a joint collaboration. It's a joint project with BIBF, working with Bahrain Polytechnic to give us the latest on artificial intelligence. And so, just to give us a recap of what we had yesterday, we were opened up, okay, with very encouraging statements from the chairman of the Board of Trustees of Bahrain Polytechnic, Sheikh bin Abdulaziz Al Khalifa, and he was followed by the governor of the Central Bank of Bahrain, Mr. Rashid Al Maraj. And of course, we had a series of interesting panel discussions. I believe we had two panel discussions that happened yesterday, experts speaking on various perspectives of artificial intelligence. Okay? And I believe we also had a couple of case studies, okay, which were also presented to us from our colleagues from the industry. And it is very, very interesting to see how far artificial intelligence has developed over the years. And if there is one thing that we are excited about day two, is that we have a series also of experts to share with us some of their perspectives, some of their shall we say, experiences with regards to artificial intelligence. Okay, and for everyone's information, we are running two streams parallel, by the way. So please feel free to shuttle back and forth according to the topics that are of interest to you. Right? So wonderful. So, ladies and gentlemen, I am Dr. Rogelio Levardo, and I will be your moderator for this particular stream. Okay, and as promised, it's 10 o'clock and we start on time. So I would like to introduce our very first speaker for day two. And he is a computer science assistant professor at the American University of Bahrain, College of Engineering. He has 16 years of experience in the IT industry, including academic research, cybersecurity, software development, professional training, and consultation. And he received his PhD in computer science from the University of Tsukuba in Japan. And this was in 2011. And his research interests include, of course, artificial intelligence, big data, cybersecurity, data mining, and of course, e-learning. So today, to talk to us and well, school us in terms of artificial intelligence and big data framework in higher education, I would like to introduce Dr. Hasan Kadhem. Hello, Dr. Hasan. How are you, sir?
Hello, Doctor. How? Good, good. Thank you.
Wonderful.
Thanks for
Thank you for being with us. And well, the floor is now yours, sir. Take it away.
Thanks. Thank you very much. So thanks, Doctor, for the introduction, and good morning, all. So I'll just share a screen to start the presentation. So today presentation, I'll speak mainly about AI, artificial intelligence, and big data framework in higher educations, how we can use these, both technologies to get more information, more insights from data collected by universities and higher education institutes. So let's start with the outline. So mainly, first, I'll start with introduction, just general introduction about the main challenges face higher education. And then we'll see just an overview about big data and AI. We'll see what are related work or previous work for using AI and big data in higher education. Then we'll see the proposed AI and big data framework, some use cases in higher education, some examples, some experiments, and the conclusion. So let's start. we know that higher education institutes face many challenges. So we can see or summarize these challenges as these 6 categories. The first one is economic challenges, such as funding, globalization, partnership, and how we reduce the operational cost. Then we'll move to regulation, such as we have increased a number of regulatory bodies. We have quality assurance and accreditation. So in Bahrain, for example, here we have HEC, Bahrain National Qualification Framework, and quality assurance. So how we can use big data and AI to overcome these challenges by preparing the benchmarking, for example, self-study reports, and so on for different regulatory bodies and accreditation bodies. The third category is related to technology, such as emerging e-learning and tools and platforms, especially now in this pandemic in COVID-19, and how we use the new sources of data and the new technologies. We have also some challenges related to research, such as funding and globalization. The challenges related to education, such as changing in learning needs, so especially in computer, for example, engineering programs, and so on, how we can measure the performance, what are the delivery methods, the best delivery method for different courses and different subjects. At the end, we have the student social challenges, such as internationalization, diversity of students, gender equality, and achievements, and the skill gap. So higher education already, generate a lot of data from different systems, from different resources. So we have the registration system, and at higher education at institutes, we have alumni data. Committees generate a lot of data, and this is not unstructured data. So we have meeting minutes, objectives, tasks, the evaluation, and so on. We have also a lot of policies and bylaws, versioning. We update all the time these policies and bylaws. We have also programs data, such as program description, program learning outcomes, the plan, the curriculum, and so on. We have also the events data organized by the university or institute, again, research data, learning management system, and many other systems. So the idea here is how higher education institutes and university use these data, the huge data or big data, to overcome the challenge, the present challenge, and get useful information and useful insight from these data. Just before we go into the framework, let's just see the big data 10 V's. So usually, many people say when they hear a big data, it's mainly about volume. But actually, the reality is not just volume. The volume, it means that if we have a petabyte and more data, huge data, this is considered a big data. But also, if we have velocity, which means that the data comes to the server or collected data and it's too fast. Variety, which means that if we have different data, we have structured data, semi-structured, and unstructured data. And even, I will not go through all these V's, and even venue, if we have data in different locations, stored in different locations. So nowadays, we have systems in-house. In data center, for example, we have system in cloud, and we have actually some data stored in PCs or in SharePoints and so on. So, and the AI, we have different analysis types. So here we are, either we want to know what happened previously, and this is a historical analysis, or we want to know what is happening now, which is the operational analysis. Then we have the analytical analysis to see why that happened. why something did happen, and then predictive to predict what will happen in future. And then we have perspective, what should I do about certain cases, and then explore more data. So we can use many different AI technologies or algorithms such as machine learning, deep learning, natural language processing, text mining, computer vision, recommendation engines, expert system, and many other algorithms and different AI types, analysis types to get information about these analysis. So the idea here is how we can use big data and AI because it is interconnected together. We cannot have AI, artificial intelligence, without data, and big data just stored in a server or different servers without analyzing them. There is no benefit from storing these data. So higher education needs to use big data and AI technology to enhance student experience, to improve academic program, and to have more effective evidence-based decision making based in actual data and actual information, and at the end also to make a strategic response to the change or the global changes. So related work. Actually, there are many different works related to big data and AI in higher education, but we can just summarize those works as mainly focus on student performance prediction. Most of the previous work use AI and big data to measure the student performance or to predict the student performance in different courses or in different programs. So we can see some research papers on performance prediction to predict at-risk detection, which means to predict the students at risk, learning system feedback, course recommendation and registration system. If we have also student skill estimation, behavior detection, grouping, and collaboration of students. So we can see all these, it's related to student performance, but in this research, we'd like just to introduce something new, which is using AI and big data, and not just to predict student performance or an issue related to student performance, but actually to have a general framework to in higher education to get benefit of AI and big data and decision making and program development. So in this research, we'll propose a general framework for in higher education, and we'll present different scenario, different use case, and then we'll see some experiments. So this is the framework. We started by having data from different resources, either internal or external resources. Then we'll have a data collector to collect these data. We need to pre-process this data using some metadata. Then data processing or AI analysis, store these data in big data storage cluster and so on. Then we'll have the data query and virtualization. And the very important layers, two layers, which is the privacy preserving layers and access layer, to have access to different access, different mechanism for different users, such as policymaker or administrative, faculty members, and registration or any other users. So what are the data sources we can import in this framework or in this system? So we start with external sources such as social networks. We have a lot of data in social networks, mainly professional networks such as LinkedIn. We have also data and different social media, Instagram, Twitter, Facebook, and so on. We have data, external data from research index database, and we need this data in all systems or analysis related to research. We have the national data and reports such as NQF report, HEC reports, and so on, international reports and international ranking, and in addition to universities and higher education institutes ranking data. While in internal resources, we have actually many different resources. We start with event data, bylaws, and policies, HR and finance, financial data, administrative data, curriculum data. We have also data related to learning management system, research, and also to faculty members, CV, experience, committees, and so on. So we can see that this system should be, I mean, this is a huge system to get benefit of different data, and these data we have in different formats. So we have structured data such as when we speak about HR and financial systems, learning management system, while we have other semi-structured data in XML or JSON format, and we have unstructured data such as the committees, reports, bylaws, policies, and so on. So this is the first use case. In this use case, actually, we need to implement an automated benchmarking by collecting data from and analyzing data from different resources. So let's say that we have the curriculum data related to the courses and the programs, and we have faculty members data who teach these courses. We have ranking database. We have data related to programs and curriculum from other universities and other higher institutes. And of course, the international and national reports. How we combine these data to develop automated benchmarking, which is very important to develop programs and to comply with different regulatory bodies and accreditation bodies. We'll see later just an experiments to analyze basic program learning outcomes between two different universities and see how we can use AI and big data to make this automated benchmarking. So the second use case is how to form effective committees and teams, either permanent committees or teams, ad hoc committees. By looking on the historical data we have related to the previous committees, faculty CVs and experience, what are the committee data, meeting minutes, and evaluation for previous committees, in addition to the objectives. And we can see that we have to use many different analyses here to form effective communities and teams. The first one we can think about it here is the role association. So sometimes we can see that in some committees, for example, it will be more productive to have these two members together in all these committees to be more productive, while we can have another example that if we have these 2 or 3 members, then the committee is not effective. The last use case is the course and instructor evaluation. Actually, we have usually, I mean, in many different universities, naive system to evaluate instructor, or let's say the traditional system to evaluate courses and instructors by using just the evaluation or survey by at the end of the course. What if we have combined different resources, different data from different resources to came with another perspective for course and instructor evaluations. So using the traditional evaluation result at the end of each course with the grades and attendance record in different courses, professional certificates for students, and social data, what students post and professional networks, what students post in different social media. In addition to program outcomes, we can come with another view of the course and instructor evaluations. So the experiment, actually we'll see just 2 experiments here. And the first experiment related to social analysis. So the idea of this experiment, there's an account in Instagram where students post different questions, comments related to courses at universities. Unfortunately, they post all these messages as a picture or image and Instagram. So the idea is we need to just classify these posts and see or assign these posts to registration if it is related to added drop time and adding chair or open section or planning and so on. If if the post is in this category, we need to assign this to the registration. While if there is some post, it's related to instructor information, what is the email of an instructor, and then we have the course material, student asking about book slides and exam date and time, and we have also some questions or posts related to instructor recommendation. So since this is in Arabic, so I used actually Python 2.7 and R 3.4. We use Python just to extract, since there is no official AI to extract all images, comments from Instagram. So we used Python to scroll on all these posts, all posts in all in this account. And then we used OCR to convert the image to the text, exclude all images without text. Then we get the data set to R 3.4. We use SVM to make the classifications. So the data set consists of 5,380 posts, and we get 5,096 image, and we have just 3 I mean, the other posts are just videos. So we have 3,929 image with text. Actually, we choose just 400 posts, and we went through all these posts to see what is the category for each post, to train the system and then test the system for the analysis. So this is the result. So the testing, we have 400 posts, 300 for training and 100 posts for testing. And the accuracy, around the best accuracy we can get here in this system, since it's really difficult and based on the language, the Arabic language, to find exactly what is the category for each post. Especially some post has approximately same keywords. So we have some false positive and false negatives. So this is the result about different categories. We have 5 categories: post related to courses, post related to just an information, recommendation, and registration, while we have the 5th category is for other posts. The second experiment, it's related to automated benchmarking. So this is a very important also analysis, and we use it till now manually in many different universities to benchmark the program to at the university to other university, local university, regional university, and international universities. So the idea here is we need to make this automated, and by using different AI techniques or AI algorithms. So we'll use semantic similarity first. So we have two different program learning outcomes from different universities, and we can see that the semantic similarity is 0.9141, which is 90% or 91%. But using just this semantic similarity, we cannot see the difference or differentiate between these two program learning outcomes. Basically because this is for computer science, and approximately most computer science program, they use A-bit program learning outcomes. So we came with this, the entity extraction algorithm to extract the main concepts, the main entity in each document, and then analyze these concepts and make the difference, see the difference between the first document and the second documents. And I believe that I didn't complete, actually, we didn't complete this experiment. We need to make it for more documents and for different programs, not just the computer science, to see the actual result for this automated benchmarking system. So this is the conclusion. We've seen first the challenge faced by higher education institutes, and we proposed AI and big data framework for higher education. We presented 3 different use cases, and we've seen just 2 experiments to analyze social networks and for the automated benchmarking. So the future directions, we need just to improve the accuracy for the social analysis, classifications, and integrate result with internal resources to get more insight. And this is the difficult part, because actually this is related to privacy issues, and university don't agree to actually, usually all university, to share this information with researchers. And the last thing is do automated benchmarking for different academic programs from different colleges. Thank you very much, and I'm happy to answer your questions if you have any questions.
Wonderful. Thank you so much, Dr. Hasan. That was very, very enlightening. Wonderful. So we are open now, ladies and gentlemen, for any questions for Dr. Hasan. I believe we have one here. So let me just read this out for you, Dr. Hasan. So what about the inaccessible data? How can we minimize its negative effects on our analyzing process, especially with collected data from surveys that may not be actually 100% accurate?
Yes, because I'm actually collecting just data. Because of that, I said the traditional way of relying on the traditional survey, it's not good. We need to support the result by using other resources. So let's say, for example, the use case we've seen is the evaluation of instructor or evaluation of course. If we rely on just the evaluation or survey by the end of the course done by students, there is no point, where students just take the scale from 1 to 5 or 0 to 5. So by combining this with other resources such as grade, attendance, social data, professional networks such as LinkedIn, and also the outcomes, the program outcomes, we can come with an insight, more knowledge about this evaluation.
Wonderful, wonderful. Thank you so much, Dr. Hasan.
Thanks, Dr.
I think we have, here, we have one more from Dr. Philippe Ringay. So are you able to predict students' future grades or performance in order to identify early students at risk?
Actually, there are many different research related to students, predicting student performance. And this research, I mean, the previous research, they have different they use different algorithms, different analysis type, and different results. While in this research, in our research, we focus more on supporting the admin part, such as how we can develop the programs, how we can construct effective teams and committees, and so on. So because there are many different previous research related to the previous the prediction of students' performance.
Definitely. So definitely it's more of a work in progress.
Yes,
Yeah,
exactly.
but definitely not impossible, I think.
Sorry?
Definitely not impossible.
It is possible, and you can. I've seen, I mean, using different research, different algorithms, you can have different result. So some research, they use linear regression associated with other algorithms, and they get, for example, less than 90% accurate. While now we have more resources, more data, more algorithms we can use, and I believe that we can reach, I mean, really an excellent accuracy for such kind of system, especially for students' performance prediction.
Wonderful. Thank you so much, Dr. Hassan, and we wish you all the best in your future research, and we hope to hear more from your developments down the line.
Thank you very much. Thanks, Victor.
Thank you so much, Dr. Hassan. Ladies and gentlemen, this was Dr. Hasan Kadhem speaking to us about AI and big data framework in higher education. Thank you so much, sir.
Thanks, Victor. Bye.